welcome back to part 4 of the ECS Getting Started series. So yeah, this video is going to be working through the six config examples. It's going to be quite a long video because it will take a while to get through. So I'll split that up into chapters so you can jump to different examples if you want to work with a particular example. You've got an easy reference to get there. So yeah, this assumes that you've already watched the first video, which tells you everything about ECS. Then the second video is on the architecture. Third video is installing ECS, and this one, fourth video, is how to use it basically. So it will take you through the 6 examples, starting from very basic, where it is pretty much emulating what you've got already with TF files feeding into your pipelines. And then we're developing on that and making the config dry, and then we're generating config when we get through to example 6. So yeah, let's get started. So the next thing we're going to do is go and grab the config examples out of the Getting Started repo, and we're going to put those in our repo just as though we had created some config. So imagine this is your server, and this would be or your config, your very first config, and let's say you've got 6 routes to your config. So this could be something like team 1, team 2, team 3, or however you want to organize this. So it could be organizational unit, country, and then you drill down to the different functions and the configurations they need. So we're going to look at example 1. Each example has a README that explains what it does. Example 1, yeah, I'll let you read over that one. But, it's basically looks very much as though if you had your own pipeline defined with some TF files, this is the kind of thing you might see in there. So maybe your your Terraform script iterates over these different user instances and creates them and manages them. There's nothing dry about this. This is exactly as most configurations would be these days. We're going to take this and we're going to make this totally dry so that we don't repeat these things. So this one's got the same instance profile, same AMI. The only difference is it's got a different instance size. So why are we repeating all that? And that's the purpose of ECS and what it solves. Also in here we've got a couple of S3 buckets and some very basic settings for that, and we've got a second user as well, and as a similar config again. Yes, what we do here for example 1, the first thing we need to do, now we've copied that in there, so we can do a config status, and this is telling you there's some new files, quite a few files in that config, and we need to push that up to the server. So because we need to push it to the server before we can build any config, because it's built by the server. So the server does all the compilation of the config and yeah, retrieves it, works with the secrets, etc. So now we're going to do sudo ECS config build -path config examples /example1, and let's see what that outputs. So as expected, there's no config output because there isn't actually any config in the example1 directory. So now let's go a little deeper, and once again, nothing because there's nothing there. So if we would now go c2.yaml, is that correct? Let's have a quick look. Instances.yaml. That is basically a TF files file that has been spat out. So in your pipeline, what you would do is you can redirect that to tffiles.json before you run your pipeline, and it, get your pipeline to consume that TF files file that's just been generated. Now, obviously, this is a very basic example and doesn't do anything that you can't do at the moment with a TF files file. So let's move on. So right there, we're looking at one single file. If I want to look at all the config for user 1, all I need to do is go. This will go and, did I spell that right? No. Recursive. Can't see it because it's jumped onto a new line. So now what it's done is it's extracted all of the config objects, so it's read all the YAML files in there, so instances and storage, and output all the config. Now the next thing we can do is we can say minus filter. Let's say we only want the EC2s, and that's just given us the EC2s, and we could drill down further and we could get just this. Let's do that. This is going to need some quotes because because it has dashes in it, and that's just giving you the config for a single instance. So you can see how you can drill down on different parts of config. Well, what else can we do in here? I think that's about it. We don't have any secrets in there, so we can't tell it whether we want it to decrypt the secrets or not. But yeah, that's the very first kind of working example. So you could set everything up and go and replace your TF files with a filing config like that. And you could keep it really simple, put it right at the root or anywhere that you like until you've decided what your structure should look like. Right, so let's move on to example 2. Example 2 is very simple. What it does is introduce the concept of merging and dryness. Do not repeat yourself in your config. So here, very simple, cut down config. We're saying we've got some common details set up in this EC2 file. And so we've got a disk size of 400 and instance type of small. But for this team, we want to override that. So 600 instead for this team. And this is very, very typical of what ECS does. So you specify your common config higher up in your hierarchy and then tell it how it's merged. So this one, because it's so simple, we don't need a merge strategy. So we'll just recall this command, get rid of the filter. We want the recursive. Let's just say example 2. And you can see it's output a merged version of that config. So imagine all your common stuff in the top level EC2 and your overrides in the subdirectories. Now it only works this simply because there's only one subdirectory, so it knows which path to traverse. If you have multiples in here and you did the same thing, then it would process them in an alphanumeric sort order, and you'd end up with one object, which is the merge of all of these. So that's why we need merge strategies for more complex examples. So let's have a look at a simple merge strategy with example 3. So let's close it to example 3. The first thing we'll do is have a look at the config. So here you'll notice that the config isn't nested. It has a common directory in the example 3 directory, and this will put our common config, and then we've got a couple of teams and some overrides. So let's have a look at common, much like we had in example 1. So it's kind of a full set of config for creating an instance. And team 1 overrides the disk size, and team 2 overrides the VPC name. So we can see we've got a VPC name specified in here of default, but team 2 has a different VPC name, so we're going to override it. Now let's have a look at how we do that. So this is a merge strategy. So you can define merge strategies anywhere in your config path. So users can define their own merge strategies if they have that permission, or you can define merge strategies at the root of your config, and they're accessible in a slightly different way by specifying default in front. So here we've got this merge strategy. I'm going to copy its name for in a little while when we actually do the merge. In fact, should we do the merge first and then we can let's get rid of all of this. Right, so we don't need recursive. We're on strategy 3, so we don't need recursive because the strategy tells it what to do. So the strategy tells us it's recursive. So what am I doing? Strategy name, and let's pass that in. And so what happened here was we've got team 1 EC2, and what do we say? Yes, it's overridden the disk size to 400, and team 2 has got a different VPC name. So you can see what it did. It took the common config, it bolt that one in first, and then it layered on the additional EC2 configs. And that is done by this strategy. So this definition in here, variable definitions is the first bit we'll look at. So this tells it where the common data is. This is just a variable name. Common data is a variable name, and directory data is a variable name. And we tell it what this means. So common data is living in the common directory. The type is data with key from object field. This one, yes, this allows us to work with data in the config. So source object path, it allows us to access objects in the path. So here we're accessing the EC2, so we don't want the EC2 at the top level, just give us everything underneath it for common. And then this one, the directory data, so you see we've got this teams directory, and this is creating a variable that we will iterate over, and we can get the key, which will be the team name, from here, and so then we can build it into our output like this. And then the actual strategy itself is basically just an iterator where it takes some data and merges other data over the top. So we have a for each of the directory data, so that's the teams, inject the common data. So remember, we've taken out the EC2 object for the very top level, and we're taking each team, each value, that's the contents of the team directory, the EC2 object, and we're merging that over the top of common, and then we're adding a parent of EC2, so we kind of preserve that back how it was. So each one of those has now got EC2. So that's a very simple merge strategy. Is there anything else in here? No, I think that's it. I'll tell you what we'll do though first. Where we specified the path, yeah, let's run the default merge strategy. So the default that lives in the root, strategy not found. Maybe we didn't call it that in the root. Let's go and have a look. So here's the root strategy file. Merge common EC2 to teams EC2. Default.merge common EC2 to teams EC2. Looks right. We'll come back to that one. I'll have to have a look when I'm not recording. So yeah, but the point of the default strategies is an admin can create strategies that can be used anywhere in the path. So when you do this, it assumes that it's replacing the config path. So when we did the merge, we say minus path, minus path, and that path will get substituted in here. So it means you don't have to have strategies all throughout your config. You can have some common strategies that are used throughout the config defined at the root level, and that means users don't need to mess around with them, see them, or understand the config strategy language. All right, so now with that explained, let's go to example 4. Okay, so right, close example 3, example 4. It's the same, basically, apart from now we've got an S3 definition in here. So these are the defaults for S3, and then at the team level, we've got the EC2 as we had before, and we've also got the S3. So here we're just overwriting the fact that this one isn't private, because if you do that. So let's have a look at the strategies file for this. So the only difference is instead we've got an extra for loop in here now, which goes over this thing called a list iterator. So it goes over these literal definitions of objects and will replace them. But we're going to learn a little bit more of what you can do in the strategies file. We can define an alias for the iterator so that we can refer to that name anywhere. So just immediately inside of for each, you have access to each.key and each.value, a bit like you would in Python. So that's immediately underneath. But as we got another loop here, another for each loop, then we don't have access to each.key and each.value for here. So if we name it, then we can access it. So use this variable, dictionary iterator, each.value. Note that's a pound sign, hash sign before each.value instead of a dollar. And then each.value here is this inside iterator, so EC2 and S3. So this will do a merge of all of the objects in these directories looping over here. So this will save you having a strategy file for each type. So you could make that list as long as you like for all the objects that you're interested in merging. So let's run this one. What's the strategy called? Let's change that to example 4 and put the strategy name on the end. And when we run this, we should get lots of things. So now you can see private is overridden for team 2, and team 1 must have been different. So what was in the common for this? Right, yes, so it's overridden it to be true. So we can do the same thing. We can do the filtering to bring out just the pieces of config we like. But yeah, so this is a more typical strategy that would be looping over certain objects. So now let's move on to example 5. So example 5, simplified again, we've just got the EC2 object in there, and we've got the 2 teams, and so we can close those because we know what they look like already. Now, oh no, we don't actually, so this is different. Let's have a look. So here, we've got our common data, so you're familiar with that, but that's the same as the other examples. But here we've got server 1 and server 2, and we're overriding some disk sizes. Now, that would not normally merge from common into this because it's not the same structure, EC2, server 1, server 2. So what we do is we use our merge strategy to iterate in a slightly different way. And what it's going to do is generate us a list of servers with the config merged in. So that might be like a TF files file, which has got multiple servers listed, and you'd have a for each in a Terraform that iterates over that and goes and manages those different instances. But the difference here is there's no duplication. So if we wanted to go and update the AMI, we could update that just in one place, and that would be reflected in the output of all the different instances. So this is a very useful strategy. So you might have a set of databases that a user needs. They might have a dev and a UAT and a prod, and so you could define those, have your common, and then just override the things. So those could be in different AWS accounts, so they'd have different AMIs, but other things might be common, like the instance profile name. They might all have the same disk size. You can imagine that at scale, where you've got a lot of teams, then that saves an awful lot of config and makes it much easier to manage. So let's go and run this merge strategy. So let's have a look. Generate EC2s, this one's called. So inject to example 5 and put in generate EC2s. And you'll see here we've got team 1 has a couple of EC2s called server 1 and server 2. And team 2 has those as well. So you can see how that's working. But we haven't looked at the strategies file, so let's have a look at how that happens. It's only a 2-level iterator because we're not doing that list iterator in here as well. So we've got the same definitions down here for our team and our directory data and our common data. And as we iterate over these, we're just accessing different levels of the object and injecting. So each value here would be the merged in EC2. So here's the common data. No, sorry, that's not the common data, that's the directory data. So each EC2, which would be instance 1 and instance 2, is accessed, and then it merges the common data and lays that over the top, lays the individual one over the top. And then we add the parent EC2, which is this bit, and we end up with a list of instances. So yeah, hopefully you can see how that can save an awful lot of config. And example 6 we'll go into now. It's not much different, apart from what we've done is we've added back the, in fact, what do we do here? Let's have a quick look. Common config. Oh, okay, right. So this shows that the file name isn't relevant. You can put the config into a single file if you want. ECS doesn't care. It will just read all the files in the directories as long as they're YAML. And so we've specified both objects in the single file. And team 1, it has bucket 1, 2, 3, and this one has a bucket called bucket default and bucket private false and various things overridden. This is how you would say, I want exactly what common has without doing any overrides. Now, what's this strategy called? Oh yes, here you can see list iterator. So this is now back to a 3 level. And let's go example 6. And now we've got EC2s and S3s. Just once again, let's just add a filter, shall we, just so you can remember what that looks like. Filter S3. Right, so we didn't get anything because we haven't specified the team name, which would be at the top. So let's have a look. Let's do team 2 S3. It was useful doing that. S3, got no dash, so I don't need that. And here, I'm going to go team 2, and I've done that the wrong way around because it's actually .s3. And now you can see we've got the S3 buckets for team 2. So yes, that's strategy 6. These are all accompanied with detailed explanations of how they're working in the README, so go ahead and check those out. The next thing we want to talk about is encryption, so putting secrets in your config. So we have the CLI, and we got the server, and then we've got your Git repo, the main Git repo where all config is. And the reason we have the CLI, or part of the reason, you're not editing things directly in the repo, or you're doing local Git commits and pushes to that repo, is because there's no guarantee that the secrets will be encrypted. Then all of your users would need access to the encryption key, and so we chose not to do it that way. So we let the server interject and take your local commits and push them further. So push them into the server encrypts them and then pushes them into the repo. So let's have a look at the encryption. As we said, we can put a secret anywhere we like in config. So right, just sort this one through. So let's put a secret in example 1 in this instance. So let's go, my secret is password. And so the first thing we want to do is push this up to the server. And what you're going to see here is the server is going to encrypt it, and then it's going to return us the new content, so we can no longer see the secret. In fact, no, that's not correct. So this is good. It doesn't know it's a secret. Okay, we have to tell what fields are secrets. So what we do here, there's a default set. You can override it with an environment variable that's in the documentation. But if you put ECS pass on the end of any key, it will encrypt it. So let's try that again. So we can see that the server has returned a new version of this file, which will be the one that we work with in future, unless you want to change the secret. So we can see we've got the secret here, and then we've got these SOPs details here that say what the key is that it was encrypted with, and you don't need to worry about this bit. You just deal with your config as normal. So you can see there's the suffix. If I want to, in my pipeline is where I'd need to access this secret. So let's do build minus path, what was it, config example 1, minus filter, and let's say EC2, and show secret. So you'd use this in your pipeline if you wanted to look at this secret. No, because I didn't put a recursive. Let's go recursive, and let's have a look. What was it? It was user 1, instance 1, and we can see my secret. So it's decrypted this for the pipeline. So in order for this to work, a user has to have the show secret permission. So you would typically not necessarily give that to all of your users. So admin users have it by default. And yes, you would give it to your service account user so it can decrypt secrets. Now, bear in mind that a service account user could be given access to a specific area of config. So just because it has that permission, it doesn't mean that it can access all of config and decrypt all the secrets. So you have a way of dividing the secrets up so teams can be the only people that know their secrets. Let's have a think. What should we talk about next? I think what we'll do next is we'll create a new user. So first of all, so we're an admin user, so let's have a look at the users we've already got. So an admin user can do that, obviously. So we just got the single user, which is me. Now let's go and create a user. So as ECS users create. This has all got help text, so you can type minus help and it will tell you all the parameters here. But let's have a user called Bob. And his given name is Bob, and the family name is Smith, and let's allow this user to read secrets. So let's say Bob Smith is actually a service account or somebody that needs to be able to look at secrets, so we'll give him read secrets. And what will happen here is it will go and create the user in the user's YAML file in your repository, encrypt their token, and it returns you the token. So if you want to create a new user, go and create that user, give them this token, and then when they do CTO ECS init, it will ask them for their token. And so you input the token, it will go and save it in the CTO ECS settings file, and then they will have access. The next thing that you do with users is you authorize them to access a particular area of config. So we would navigate to the directory we want to give them access to. So let's go to, I can't type today, example 1. So we go into this directory, and then we would do CTO ECS users auth action add minus Bob. Are you sure you want to add Bob to this path? Yes. So Bob can have multiple paths that he's able to access, and then when you do a config, when he does a config pull, he would only get that specific area of config. So he doesn't get example 2, 3, 4. So that's how you would divide this up with the users. I'm not going to switch to this user because it's a bit of a faff going and editing the files. But if I did that and had a new repo set up, a new directory, empty directory, when I did pull, all I would get is example 1. So that is very basic on users. There's a few commands such as you can remove somebody from being authorized for a directory, and you can see which directories they have access to, but it's all in the documentation, so you can go and check that out there. So let's just have a quick look at an example of what would happen in a pipeline. So we did talk about it quickly, but always better to do a visual. So let's have a look at a Jenkins file. So yeah, very simple Jenkins file. What is it doing? It takes a parameter of user, and it will do an ECS config. So yeah, retrieves the configuration variables from ECS. So ECS config build, as we've been doing over and over again. The path of users, merge common. I think that was our second strategy, very basic one. And in here, we're passing in the filter parameter using the Jenkins parameter, and it will go and extract the config for whatever username is passed in the Jenkins parameters with a minus out. So yeah, instead of redirecting, you can use minus out and redirect it to this file. And then the next thing it does is a Terraform apply with an auto approve with a var file of this file name that we outputted. So as you can see, instead of storing TF-vars, you can store it in the ECS server system, and this command will go and pull it locally. So whatever you're using for your pipelines, Jenkins, what else might you use? Atlantis, Terraform Cloud, you can incorporate this in there just to pull the variables just in time. Now, I've just brought up the documentation to remind myself if there's any other features that I should talk about, and here's one. As you see, webhook support coming soon. So yeah, we're just working on this at the moment. So what will happen is you drop in a webhook config into the path, any path in the config, and when you go and make a change, so you do an ECS config push, and it affects that area of config. So let's say a merge will go down to that area and create a different output, then it will trigger that webhook. So it's a bit like you know, GitHub webhooks, except we're doing it in the ECS server. So yeah, a change can go and trigger a multitude of pipelines that will be affected. So if you change something in common, it could trigger a lot of pipelines. So that feature is coming soon. And I think that is pretty much what we need to cover in this video. So yes, so let's head on to our website if you want to have a go. The Enterprise Configuration Service, it's not there yet because we haven't launched, but in a few days' time this will appear. And let's just have a quick look. It's going to look a little bit like this. So you'll go to the pricing and just select the free trial, and it will take you to a form. You just put in your organization name and first name, last name, email, and hit this, and then we will email you an API key. Then you can download the Getting Started repo, and pretty much you've got everything you need to do exactly what I've done. So then you just go build out your first config, which could be a bit like example 1, go and do something in a Jenkins file like I've done, so to replace your TF-vars. With that, you run that locally, depends on your Jenkins. If it can, you could use ngrok to be able to access your local config running with Docker Compose, or you could just deploy it to whatever your container system is, Fargate or Kubernetes, and run it there. So yeah, thank you very much for watching. It's been quite a long video, but there's a lot of stuff to go over. Yeah, really appreciate your time, and I hope you sign up and have a go with it.